Let's continue our discussion about context-free grammar, specifically ambiguous grammar. Ambiguous grammar is a context-free grammar wherein we could derive more than one derivation tree to determine or to derive the desired input. So for example, we have this production rule. X yield to X plus X or X times X or terminal A. The desired input is A plus A times A. Okay, so let's derive the production or let's derive the input based on the production rule. So start symbol X. Okay, so from X we have two options. The first option, X plus X or X times X. So for my first solution, we're going to choose the first option, X plus X, which is equivalent to the first three symbol of our input. Okay, so X plus X. And then we're going to replace this node by the second rule because the second operation is multiplication. Multiplication is in production rule or in option 2. Okay, so X will be replaced by X times X. And check if these nodes have the same format as this. A plus A times A. X plus X times X. So therefore, we obtain the correct format. Now, so we're going to replace X by the fourth option, which is A. So we have A here. And this second X will be replaced by A again by the fourth option. And this X will be replaced again by A by the fourth option. And when we read it from left to right, A plus A times A, which is the same as this. Okay, so another solution could be, instead of X plus X, we're going to utilize the second option, X times X. Okay, so second tree will be, always start with the first symbol for our root node, then replace it by the second option, X times X. And since we already obtained this format, now we need to have plus. So we're going to replace X by the first rule. So we have X plus X. And by looking at this format, X plus X times X is the same as our input. Now we could replace all non-terminal with terminal A. And we have obtained the desired input, same as with the first three. So as you can see, first tree, second tree derive the desired input. And we have two decision or derivation tree rather. Okay, so therefore this production rule from a grammar, certain grammar, this grammar is ambiguous. Okay, another example. We have these two rules. S yields to ASB or SS. S yields to null. And we are requested to get AA, BB. Okay, so let's start to create a tree, this derivation tree. So let's start with S. We have three options, null, ASB, SS. So for me, I'm going to use SS. Okay, for the first S, I'm going to replace it by what? By null. Okay, later you're going to find out why null. Okay, and then the second S will be replaced by ASB. And as you can see, we already obtained the first and the fourth symbol. So now the problem is this AB at the middle. So S will be replaced again by ASB. So we have this. And then compare the end node, empty AASBB. Empty could be removed with our string, or null could be removed in our string. So we only have AASBB. We already obtained AABB, but we have an excess S. So we need to remove this so that we could obtain the desired input by replacing S by null. So now we have null AA null BB, or basically just AABB, which yields to this input. So this is our first decision tree. Second decision tree. Start with S again, but instead of SS, we're going to utilize the first option to replace S. So we have A, S, B, then S will be replaced by, again, AS, B, and then S will be replaced by null, since we already obtained the first two A's and the last two B's. So this would be our second decision, our second derivation tree. AA, null BB, or just basically AABB, which is the same as our input. So first derivation tree derives the same input as the second derivation tree. Okay, so therefore, this grammar that represented by this production rule is ambiguous grammar. Okay, so that's it for this video lecture. See you on the next. Thank you for listening.